a change in X and Y. So number 1, your slope was equal to 7.3 minus 9 over 3.4 minus a minus. So 7.3 minus 9 gave you negative 1.7 over 3.4 minus a minus. So that's like a plus 0.2. So you get over 3.6. We can't have decimals in fractions. So you can move each decimal to the right one and you get negative 17 over 36. Number 2, 13.5 minus 17 over 11.5 minus 10. So 13.5 minus 17 gives negative 3.5. 11.5 minus 10 gives 1.5. So we have negative 3.5 over 1.5. So if you type that in on your calculator, you get negative 2.3333 repeating. You do not want a decimal, so you have to hit math, enter, and that would turn it to a fraction. Or you could simplify on your own to have negative 35 over 15. But that reduces because they both divide by 5 to negative 7/3. And then we have that the slope is 2/5 minus 3/10 over negative 1 minus 0. So again, 2/5 minus 3/10 is the same as 1/10 over negative 1, which is really just negative 1/10. So today we're going to continue looking at slope. We're going to continue to find slope, but now we're going to do that by creating our own line given a scatter plot of data. So a scatter plot is a set of bivariate data graphed as ordered pairs in a coordinate plane. Bivariate simply just means data in two variables. So it's bivariate data or data that has two variables graphed as an ordered pair. Our line of best fit or trend line is a line that closely approximates the data. Our line of best fit or a trend line is a line that closely approximates the data. And then we're going to talk about line of best fit, which is the line we draw, versus a prediction equation or a linear regression that come from the calculator. So there are two types of lines we're going to talk about, lines that we draw and lines that come from the graphing calculator. Okay? Lines can be described in a variety of ways. They are described as strong or weak. They are described as positive or negative. And if they are a scattering of points with no relationship, then we say they have no correlation. So we can describe lines in a variety of ways. They're strong or weak. They can be correlated or not correlated. Yes. No. So like the very last one is no correlation at all. Okay, so an expert at an art gallery visited the gallery and jotted down her guesses for the selling prices of 5 different paintings. Then she checked with their actual prices. So we're comparing her guesses to the actual. We're going to draw in a scatter plot to make that comparison. So we are going to plot some points. We have 12, 11. So she guessed that the painting was $12,000, but it was actually 11. So that will be my first point. She guessed that a painting was $7,000, but it turned out to be 8.5. She guessed it was 10,000, and it turned out to be 12. She guessed it was 5, and it turned out to be 3.8. And she guessed it to be 9, and it turned out to be 10. So I would say, looking at those scatter plots, that they look to be pretty close together. It looks like they are increasing. So as her guess cost increased, the actual cost of the painting increased. So it says, decide whether a linear model is reasonable. So I would say, yes, it is. The correlation between them seems to be pretty strong because the points are pretty close together and they're going up, so it's positive. So then it says to draw a trend line and write our equation. So the trend line is the line you draw. So I would say, if I were drawing in a line, that maybe her guesses and the actual were always a little bit off. So you're looking to try to just like get the same number of points above and below, kind of equally distance them. So you'll notice I have these 2 points down here, those few up there. So kind of somewhere in here gives me a good estimate of my graph. And again, it doesn't have to be perfect. It may not be. I have 3 above, 2 below. They're all kind of equally distanced. Yours might be a little different from mine. That's okay. So what I'm going to do is pick some points on my line and create a slope. So to me, it looks like I have the point 9, and then I also appear to have the point, let's say 5, 4.5. So my slope would be 9 minus 4.5 over 9 minus 5. So I get 4.5 over 4, and 4.5 over 4 is kind of like 9 over 8. So what that means is that the actual was a little bit more than my guess most of the time. To get the equation of a line, you need to use a point and your slope. So I might say y minus 9 equals 9/8 x minus 9. Or y equals 9/8 x. And then 9/8 times -9 plus 9 gives a minus 9/8. And that should make sense because if this line here were to continue, my y-intercept would be negative. And that is how you find the equation of a trend line. So for today, we are focusing on plotting points. And finding the slope of those points, and then being able to find the equation using that slope. So let's look at one more example. So this time we have the data in years since 1984. So let me get myself a table. Actually, I can just do this. The table look exactly like yours. Let's plot our points. So the years are going to be on the bottom and the percents go up the side. So it's important to kind of write that or label it. And you have to make sure when you do your years that you write them evenly. So we're going to start with 1980. But then I don't go to 84. If I'm going to do this, I'm going to do it probably by 5s. So you're going to go to 85. Then to 90. Then 95. 2000. 2005. 2010. 2015. So again, you're evenly spacing them by 5 years. You cannot write the years in the table. You have to evenly space them, just like the percents. We'll go up the graph by 10. So it's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I'm going by tens. So that when I plot my points, they're also evenly spaced to get that idea of the correlation. So in 84, a little bit before 85, it's at 8.4. So that point would be just inside that box right there. 89, which is a little bit before 90, is at 15. So kind of centered on that box there. 93 would be between 90 and 95, and it's just past 20. 97 would be between 95 and 2000. It's at 36.6. 01 is at 56.3. 03 is at 61.8. So those two are kind of close together. They're both between the 00 and the 05. Then we jump all the way to 2010, which is near 77, which is going to be near 80 and on our line. So again, I can look at this data and be like, okay, it is increasing. So therefore, it would be a positive correlation. They look pretty close together and pretty linear, so it is strong. I'm going to draw in my line. So again, I have like an even number of points above, an even number of points below. Doesn't always have to go through a point. This one just ironically went through that 2010 76 point. I'm going to pick points on my line though. So I'm going to go with like this point in the corner here and this point in my corner there. So I'm going to use the point 1985 and 10. And then I'm going to use the point 2015 and 90. So then 90 minus 10 over 2015 minus 1985 gives 80 over 30, or 8/3. So then my equation is y minus 10 equals 8/3 x minus 1985. And you can leave your equation like this. If you wanted to solve for 10 but not distribute your negative, you could say 8/3 x minus 1985 and then throw the plus 10 after the parentheses. What we're going to move on to Please ask your max. What we're going to move on to after this is that we are going to start looking for data or predicting data. So the question might follow, what was the percent in 2008? So you could pick a line or a number. And the idea would be that it wants to know what is the predicted percent in 2008. So what we would do is take 2008, that's an X value. So you'd plug it in for X in your equation. So you would have Y equals 8/3 times 2008 minus 1985 plus 10. And then you would use, a calculator, and you'd say, okay, 2008 minus 1985 times 8/3 plus 10. And we get that the prediction in 2008 is 71.3%. And again, if you went to your graph, 08 would be in between 5 and 10. And we could even see kind of like from that graph, it's near that 70. So our trend line matches our equation, which matches our graph. So you have 4 problems for homework. For each of those problems, you're drawing the graph, rating 2 ordered pairs to get me a slope, and then using that to find the question mark. So like in number 3, I had you guys plug in 2008 for this example. And number 3 on the homework, you're looking for 2009.